Okay, let's dive right into this. Welcome to this explainer on America's space economy. Today, we're unpacking how space is transformed from, this distant, cold frontier of just scientific exploration into the literal, invisible engine that powers our modern lives. Seriously, if you think space is just about astronauts and distant planets, well, prepare to have your perspective completely shifted. So, I wanted you to start by zooming out conceptually for a second and asking yourself this. What on earth does your ATM have to do with outer space? Now, I know it sounds like a trick question, but I promise it's not. Actually, every single time you withdraw cash, you are directly interacting with a massive infrastructure orbiting hundreds of miles above your head. Crazy, right? In fact, space powers your day in ways you probably don't even realize. Think about it. You use GPS on your smartphone. You make those ATM transactions. You rely on global internet. You check weather apps to dodge a rainstorm. And hey, if you're traveling, your flight is literally navigated via satellite. Space is absolutely no longer just a destination to visit. It is an active, booming sector of the global economy worth hundreds of billions of dollars. But to really understand how we got here, we need to take a quick look back. Which brings us to Section 1, from NASA to commercial. So, looking back at 1957, the launch of Sputnik really kicked off this intense geopolitical race for national prestige. The U.S. responded by establishing NASA the very next year in 1958, which of course led to the monumental Apollo moon landing in 1969. But notice the shift as we move forward in time. By the 1980s, the Space Shuttle introduced this groundbreaking concept of a partially reusable spacecraft. And then as we cross over into the 2000s and beyond, we enter a completely different paradigm altogether. We're talking about the commercial space era. And this brilliantly illustrates just how staggering the fundamental difference between these eras really is. The old space economy, exclusively government-led. It relied entirely on single-use rockets. I mean, imagine flying a 747 from New York to London and then just throwing the airplane away after one flight. Obviously, that kept costs astronomically high and development cycles incredibly slow. The new space economy, on the flip side, is driven by private companies using reusable rockets. This newfound agility has dramatically lowered costs and essentially opened the floodgates to private investment. Now, you might assume this means NASA is just stepping aside. But actually, it's the exact opposite. Today, NASA increasingly serves as an anchor customer, a technology incubator, a research leader, and a real catalyst for innovation. So instead of owning and operating every single spacecraft themselves, NASA now partners with private industry through initiatives like the Commercial Cargo and Commercial Crew programs. They're essentially buying transportation services from these companies rather than building the vehicles in-house. And that has completely changed the economic landscape. Let's move on to Section 2, Reusable Rockets Change Everything. For decades, rockets were used just once and then unceremoniously dumped right into the ocean. But companies like SpaceX came along and pioneered this mind-bending new process. Think about it. You launch the payload to orbit. Then, the massive booster separates, literally reignites its engines, and steers itself backwards through the atmosphere to land vertically on a drone ship. And then, you refurbish it and fly the whole thing again. It is absolutely incredible engineering that completely rewrites the rules of what's possible. And the financial impact of this capability is just staggering. By recovering these boosters, we are preserving tens of millions of dollars in highly advanced hardware per single launch. This reusability has completely cratered the price of access to space. We're talking about a massive, massive reduction in the cost per kilogram to reach orbit. What that means is universities, tech startups, and even smaller nations can suddenly afford to put their own technology into space. It's a real game changer. Let's move to and see how this builds into Section 3, the satellite backbone. When we think of GPS, most of us usually just picture the maps on our phones, right? But its true power runs so much deeper. It guides aviation flight paths and major maritime shipping routes. It optimizes trucking logistics and even guides tractors for precision agriculture. The crucial point here is this. GPS provides hyper-precise timing signals. Global banks literally use those exact signals to synchronize millions of electronic financial transactions every day. Our electric grids use it to balance power distribution. Quite literally, if GPS goes down, modern infrastructure simply grinds to a halt. And the satellites themselves are evolving super rapidly, mostly due to miniaturization. Thanks to some truly astonishing advances in electronics, we now have things called CubeSats. These are satellites often no bigger than a shoebox. And the crazy thing is, these tiny devices can perform the exact same tasks, like high-resolution Earth observation and beaming global internet, that once required massive, multi-million-dollar spacecraft the size of a school bus. Now startups are launching massive constellations of these small satellites, creating vast networks that essentially blanket the entire globe. Which leads us nicely into Section 4, the next industrial frontier. To truly grasp what this new frontier looks like, we really have to understand microgravity. It's basically a condition in space where objects experience continuous freefall. Now, you might be wondering, why does this even matter for industry? Well, on Earth, gravity actually interferes with manufacturing. Liquids settle, crystals grow unevenly, it's a whole thing. But in microgravity, you can manufacture absolutely flawless fiber optics or grow perfect protein crystals. And it turns out those perfect crystals are actively helping us design incredibly advanced pharmaceutical treatments for devastating diseases like cancer and Alzheimer's. There's no way we could do that on Earth. All of this opens up distinctly new markets, really depending on how far out into space you go. Right here in low Earth orbit, just above us, the main focus is that microgravity manufacturing for pharmaceuticals and advanced materials we just talked about. Push a bit further out, and we have the Artemis moon economy, centering on the lunar South Pole, which aims to build permanent infrastructure and research outposts. And if we look even further out into deep space, the ultimate target is asteroid mining. That means intercepting near-Earth asteroids to extract incredibly valuable resources like water and metals. But here's the catch. If we want a permanent presence out there, hauling heavy resources all the way from Earth it's like trying to build a house by carrying every single brick from another continent. It's just way too expensive. Now, what's really interesting about this slide is the solution: in situ resource utilization, or ISRU. Basically, this means extracting local resources, like lunar water ice, and turning it into drinking water, breathable oxygen, and even rocket fuel, right there on the moon. It's a massive, massive cost cutter that actually makes deep space exploration economically viable for the first time. That brings us to our final area, Section 5, the global space race and risks. Okay. Let's take a clear-eyed look at the immediate threats to this booming economy. First up is orbital debris. We have thousands of spent rocket stages and dead satellites up there moving at a mind-boggling 25,000 kilometers per hour. At that speed, even a tiny paint fragment can literally destroy a working satellite. And remember what we discussed earlier. If a satellite goes down, so does the GPS timing that your local bank relies on. Then you add in serious cybersecurity vulnerabilities because we have to protect these vital networks from hacking and signal jamming. Combine all that with global supply chain disruptions for aerospace parts and some seriously complex regulatory hurdles, and yeah, it's a very difficult environment to navigate safely. Now, alongside those operational risks, we are also seeing intensifying strategic competition between the United States and China. Over the past 2 decades, China has rapidly advanced its space program. They've successfully developed their own permanently occupied space station, they've returned lunar samples back to Earth, and they've successfully explored Mars. Both nations are now investing heavily in reusable rockets, fostering commercial partnerships, and planning future lunar infrastructure. So we are definitely seeing the engines firing on a new, highly competitive era of global space development. So, as we wrap up this explainer, I think the key takeaway is incredibly clear. The frontier of economic growth is officially expanding far beyond the boundaries of our own planet. Space is absolutely no longer just a distant laboratory for scientific curiosity. Through a mix of government vision and private sector agility, it has truly transformed into the invisible engine of the modern world, silently supporting everything from your local ATM to complex global logistics. Which leaves us with one final profound thought to chew on. Space is clearly already the engine of today, but as we look toward lunar bases, asteroid mining, and sprawling commercial space stations, who will own the economy of tomorrow? It's a massive question, and honestly, the answer will likely define the next century of human history. Thank you so much for joining me for this explainer today, and as always, keep your eyes on the skies.